Hello everyone, welcome to my channel Quantum Ideas. So today I will be discussing some of the important concepts related to exponential model, and there are several questions ranging from very easy difficulty to very hard questions. So let's get started. Okay, let's see number one. The equation E as a function of time equals 5 1.8 to the power t gives the estimated number of employees at a restaurant, where t is the number of years since the restaurant opened. Which of the following is the best interpretation of the number 5 in this context? Okay, in this case, we even don't have to look after the options. We can just check out the question. Okay, we have to interpret it here the meaning of this 5 in this equation. To do that, what we can say here is we get the value of e as 5 when we plug the value of t as 0, right? So when you plug the value of t as 0, means 1.8 to the power 0 is 1. In that case, the value of e, when you plug t as 0, we get the value 5. So what is t? T is the number of years since the restaurant opened. T0 means it is the there is zero number of years, means it is the time of opening of the restaurant, right? That means it is the estimated number of employees when the restaurant was opened. So let's see the option. First, the estimated number of employees when the restaurant opened. Okay, that is our answer, so we can simply highlight it. Okay, so let's move to number 2. Let's read the question. The function fx equals 206 1.034 to the power x models the value in dollar. Okay, this function is actually the money equation of a certain bank account. Okay, dollar in certain bank account by the end of each year from 1957 through 1972, where x is the number of year after 1957. Okay, this is the point to be noted. X is the number of years after 1957. Which of the following is the best interpretation of f of 5 is the approximately equals to 243 in this context? Okay, again, the value of x is given, so f of x, right? This is the function, so f of x means f of 5. Okay, this equals 206 1.034 to the power, what is our x? X is 5. Okay, value of x is 5, and basically what is x? So we have to interpret it here. So x is the number of year after 1957, means after 1957 if you add x, that is 5 years, it becomes if you add 1957 plus 5 years, that is 1962, right? So basically this is the money at 1962. So that means x equals to 5 means the year is 1962, and f of x is basically dollar in the certain bank account, right? That is 243 dollar is in the bank account at when the date is 1962. So let's see the option. The value of the bank account is estimated to be approximated by $5 greater. No, the value of bank account is estimated to approximated $243 in 1962. That's right? After 5 years means 1962, and f of this function is basically a dollar, that is 243. So this is our answer. So B is our answer. Okay, let's move to next one. Let's see number 3. The function f of t equals 60,000 2 to the power t over 410 gives the number of bacteria in a population t minutes after an initial observation. How much time in minutes does it take for the number of bacteria in the population to double? So this is actually a exponential growth involving 2 as a growth factor. Okay, so in this case, let me show you the first how we write the equation. So basically this kind of equation is represented as y equals a b to the power t over n. So a is the initial value, b is called growth factor, and t is the total time passed, okay, or elapsed. This is the total time, and n is the time for population to grow by factor b. Okay, so it is time taken. Okay, let me show you with the example. For example, this is our equation, right? This is our equation. So 60,000 is actually what this initial population, 2 is the growth factor. Now this t is the total time, and this 410 is what? This is the time for the population to change by this growth factor, right? To grow by this factor, that is 2, means the denominator will denote the time for the population to double. So our answer is, how much time in minutes does it take for the number of bacteria in population to double? The answer is 410 minutes. That's our answer. Simple, right? So you can directly say that is 410 minutes. And in another way, you can also solve like this. When you equate the power, this power equals to 1. Okay, when this thing equals to 1, at that time what happens? This power vanishes, and 6000 into 2, right? This means population will be doubled. That means you can find the value of this t for doubling by just equating t over 410 with 1, and you will get the value of t as 410 as well. Okay, that's it. That will be also answer. Means you can also say, when you equal this power to the 1, this growth rate will denote the number of bacteria growing per minute. Okay, 2 means bacteria are growing 2 per minute. Okay, you can also estimate like that. So there are multiple ways to solve this problem. Okay, let's see number 4. So we have given a function, and okay, we should also very much remember that this numerator and this denominators will have the same unit. Okay, this will have same unit, just remember that. Let's go to number 4. So we have given this function, and the function f gives the value in dollars. Okay, this is the dollar equation of a certain piece of equipment after x month of use. Okay, if the value of the equipment decreases each year by p% each year of its value preceding year, what is the value of p? So this is the depreciation rate, and this is the p% every year, and x is in month. Remember that x is in month, right? Number of month used. Okay, and let's see again, I'm going to show you this again. So this numerator and denominators will have the same equation, right? Since this x is in month, this is also in month, no problem for that. Now this is the case in which the price will decrease by certain rate, certain p% every year, and this is the case for what? Exponential decay. Okay, so we can represent this kind of equation as y equals a 1 minus r% to the power t. T is in year, r is what? R is a decrease percent, right? Every year, rate of decrement. Now let's look at our equation carefully. So this is our equation, correct? Correct. And we have to understand, to find this r, this will represent the rate for 1 year, decreasing rate for 1 year, if the power represents 1 year, right? Power represent 1 year. So for 1 year, since x is in month, this value of x is 12 month, right? For 1 year, the value of x is 12 month. When you plug here 12 and this 12 is gone, in that case this quantity 0.64 will represent 1 minus r, right? So 1 minus r equals 0.64. You can find the value of r is 0.36, that is 36%. So your answer is 36. Okay, p is in percent, so 36 is your answer. You got it? Okay, let me move to next one, number 5. Bacteria. We did bacteria? No. Bacteria are growing in a liquid growth medium. There were 30000, okay, this amount cells per millimeter during an initial observation. Okay, this is the initial number, this is a, right? The number of cells per millimeter doubles every 3 hours. So this is the rate doubling, right? So every 3 hours it doubles. How many cells per millimeter will there be 15 hours after the initial observation? Again, very easy. This is the case of population doubling, right? So again, this formula will play very handy here. So let's see. So we have y equals to a 2 to the power t over n, right? Now what I have already told you, that a is the initial population. If I have to write, I'll write like this. What are the initial? This is the initial amount, right? So 300,000 2 to the power, what is t is the total time. What is the total time? Is given 15 hours. And what is n? N is the time that it takes to double the population, right? So doubles, every 3 hours, that is 3. So this is the time in which the population doubles. So basically this is 300,000 2 to the power 5. 2 to the power 5 is how much? 2 to the 4, 4 to 8, 8 to 16 to 32. Okay, this is 32. Now just multiply by 3. 3 2 is 6, 3 3 is 9. So remaining 0 are there. So this is your answer. So D is your answer. Okay, you can solve it very easily like this kind of problem. So let's see number 6. So this is our function. The given function P model the population of the lowell T years after a census. Okay, this T is in year, remember. Which of the following function best models the population of lowell a month after the census? Okay, basically what the question is saying, that this equation is represented as the function of time. Okay, this time is in year, but we have to convert this time in term of month. So in term of month, so what we can do? Very easy. So let's see. So for example, this is T year, right? So how many month in T years? That is basically how many month? 1 year has like 12 months, means T year will have 12 into T months, right? 12 into T months. Okay, 12 into T months. That means according to our equation, that will be equals to total month, that will be equals to M. That's it. Now you can represent the number of year T as M over 12. This go to that side, that is M over 12. Okay, so see here, now we can write this equation as, okay, P is changed to according to option, that is R. Now T becomes M, everything is same, no problem. Okay, and this is 1.06 to the power T becomes M over 12, simple. So that is your answer. You can do like that. Okay, you got it. Then our answer is, let's see the option. Okay, not this one, I think it's the D. D is your answer. So simply, and you have to also remember, I've already told you the units will be same, right? This is in month, this 12 is also in month. For example, for 1 year, what happens? You have to plug M equals to how many? 12, right? That gives 1 year. For 2 year, what value of M is? 24. In that way you can solve it. Okay, okay, I've written here also, no problem. And another way to do directly is like that. You can do like this. For example, we have 90,000, 1.06, there is the T. Since we should have what, the unit of numerator and denominator will be same. So there is, if there is nothing, that means there is the 1 in the denominator. Now just convert it. So we have to convert it T as T into the month, that is M month, and in 1 year, there will be 12 months. So simply you can also calculate like this. Okay, so let's move to next number, that is 7. Okay, quite long. A model estimates that at the end of each year from 2015 to 2020, the number of squirrels in a population was 150% more than the number of squirrels in the population at the end of previous year. Okay, this is the population growth rate. The model estimate that at the end of 2016 there are 180 squirrels in the population. Which of the following represents this model, where n is the estimated number of squirrels in the population t years after the end of 2015 and t is less or equals to 5? Okay, so what are the information? Let's see. First of all, 1%, 150% is our rate. So I have just taken here. So rate is 150% is 1.5, and you can see here basically this is the case of exponential growth. So this is our equation, right? Y equals a 1 plus r to the power t. So we don't know what is the initial population, we don't know, we need to calculate, that is the main point. And 1 plus our rate is 1.5, and this is the time, there should be no problem. And if you simplify you get y equals a 2.5 to the power t. Our main challenge is to find what? A, the value of a. So how to find the value of a, and that is quite important, and there is a hint given below, so you have to very carefully understand it. Okay, let's see. Okay, the mode estimate that at the end of 2016, okay, at the end of 2016 there are 180 squirrel in the population. So at the end of 2016, right? Which of the following represents this model when n, where n is the estimated number of square population t years after the end of 2015 to calculate, right? Okay. Now see here, main point is we have to find so t years after the end of 2015, right? So date start from end of 2015, right? T start from end of 2015, and the more estimate that the end of 2016 there were 180 squirrel. So if we take from end of 2015 is our beginning, and there is a point given end of 2060. At this point, okay, at this point the population of the squirrel was 180. That means from end of 2015, to end of 2016, that is in 1 year, number of y, okay, basically our y is denoted by n, okay, in our equation. This is basically y is n. So number of squirrel is 180. So we can plug it in our equation, this one. So that means the population of the squirrel was 180 in t equals to 1 year. That is a 2.5 to the power 1. Okay, that is the point. Now the value of a will be simply 180 divided over 2.5, and you will get the answer as 72. So let's see the option. So our final answer is n equals a 72 2.5 to the power t. So our main challenge here was to find what? To find out the this initial value of the squirrel population. That's it. That was our challenge, and the question was a little bit tricky. So we have to give focus, then we can easily solve this kind of problem. So our answer, let's check which is our answer. So 2.5 to the power 3. So this B is our answer, right? Yeah. So let's move to next one. I think it's the last question. Okay, after doing this number 6, it is quite similar. You can simply do. So let's see. So this is our equation. The function p models the population in thousands of a city t years. So this t is also in years after 2003. According to the model, the population is predicted to increase by 4% every n month. Okay, it increases by 4% every n months. What is the value of n? Means again, the equation is in t years, but we have to change it into month. So I've already explained you here, right? So t years means 12 into t months, that is denoted by n here, and t will be simply n by 12. Now plug it in the equation. So let me write that equation again below, and I'll be solving. Okay, so p of t equals 260 1.04, right? And there is how much? 3 by 2. And what is our t? See here, this t is n by 12, right? In term of month, n by 12. If you cancel by 4, 3, that is 3 for 12. So our equation look like 260 1.04 n over 8. Okay, basically what that means, okay, let me write it in another way. This is 1 plus 0.04, right? N power 8, n over 8. So this is again 60 1 plus, this is 4%, right? That is n by 8. What is the meaning of this? This is the total month, and this 4% increment happens every 8 month. Simple. So our answer is 8. Our answer is simply 8. Okay. Okay, now again I have also explained you to do like this also. This is the way. Let me show you again. You can do directly here also to find that. Simply what you have to do, this power, just open the power, that is 3 by 2t, right? And you don't have to do anything, don't touch this constant, just do is this is a t. I have already told you numerator and denominator should have same unit. So if there is nothing, there is 1, just remember 1, right? Now convert it into its equivalent, that is 3 by 2 is there. T month, we have to convert it into n months, right? 2 years, sorry, t years should be converted into n month, and 1 year is equivalent to how much? 12 months, sorry. Okay, so 12 months. If you solve this, you will get simply n by 8. That means every out of total month out of total month in every 8 month the population will increase by 4%. So our answer is 8. So in this way you can also solve. Okay, so guys, thank you for watching. I'll be posting more and more sad videos if possible. So if you like my video, then don't forget to subscribe, share with your friends. All the best for your SAT exams. So thank you, bye bye, see you till the next video.